nervous before the training I had to do. The first one I had to do before like the entire district. I ended up having 100 each session. I did 3 sessions. I had 300 teachers come through a training. And it wasn't until I decided I need to turn on the music, and then I finally, that like calmed me down. And I'm not really a music person. I don't listen to it outside of playing the playlist for you guys. All right, let me go into our Google Classroom really quick. 4th period. I'll show you where the notes are. Okay. Okay, so I believe well, I didn't put it there. I put them up sometime. Notebook, it's right there under notebook. And then I learned the other day that some of us need some help learning how to print. So there's the notebook that you should be working on. I don't think I have all of it. There's pieces of it that are missing. Like, don't print that page, the learning log page yet. I don't have that one ready yet, but I just gave you the whole notebook that I had ready. So I'll keep adding on to it. So if you are you can write it by hand. You do not have to print it, okay, until I get my act together and can get you more pages up at school, okay, and have them printed for you. You can write it all by hand. That's fine. And these aren't too terrible to write by hand. So you're looking for this page right here that says page 24. It's topic 6.4 and 6.5. We're not going to do all of it today. We're going to do page 24 and 25. So to print, you hit the print button or Control P. If you just want to print certain pages, well, you have to hit it again. All right. You can absolutely, David, use Cami. Okay, so if you guys have figured out how to use Cami and you've got a stylus and a device that'll do it, 100%, I want you to do that, okay? If you guys don't know what we're talking about and you have a device that's touchscreen and can be written on, start exploring and playing with Cami, okay? Yeah, please do that. And then that's so much easier for me, okay? And then you can just PDF it and send me please do that. Okay, use the technology. If I could, I would have us all doing that, but I can't do that because not everybody has that kind of device, okay? So you are 100% welcome to do that if you have the ability. So when you are printing, okay, you wanna come in here to where it says pages and go to custom, and then just type in the ones you wanted. So we said today was 24, 25, and you will just notice that page even popped up, the one I wanted. And you will print, but make sure that the page number, sometimes my page number doesn't match what I say. Sometimes it says 24 on the bottom, but it's not really page 24 in the file. So just make sure that matches up. Okay. So that should hopefully get you printing the right way. Okay. And you don't have to print the entire thing every time. Please don't do that because that's a ridiculous amount of paper and ink. Okay. And you don't have to print in color either. You can always print, you can always change. I know that I have a color printer, but it lets me change to, instead of color, I'll switch to black and white. Okay, and then I use only my black and white ink, which is not really much cheaper than the color. But all right, so that's where we're at there. I think I need to. I'm going to put these guys on a different screen while I fix up the. Actually, yeah, I'm going to put this on. You can start writing. That's why, because I forgot to whatchamacallit, I didn't get a new page in there for your class, okay? So I will share that part and fix it up while you're writing these. And then I think the recorder is already going, isn't it? Yeah, it's already recording. We'll have to cut some of it. Okay, so write your I can statements, write your EQs there. I'm gonna unshare and reshare here in just a second so I can fix this up on this machine. It's really funny because I know I talk to myself. It's just kind of who I am, but it's funny to listen to my son do it because he is the one that is most like me, the 8-year-old. And now I can't get this stupid thing to go away. There we go. All right, there they are, nice and pretty for you. Okay, you do that while I fix up the notes. This is kind of super fun. I'm just insert more. 24 and 25. The other ones beyond that, 26-ish, 27 we'll probably use on Monday. I don't know if there is a 27. There's a lot of blank ones that I haven't filled in yet. 24, start with 24, okay? So it'll be 24 and 25 today. We'll get to some of 25. Okay, I'm almost there. All right, here we go. I'm gonna unshare and reshare again. Yes, David. Figure out how to get them put together, okay? So if you're using Cami and you're using multiple, remember you can use PDF Candy. Let me show you really quick, okay? It's printing. Gabby likes her paper. All right, let me show you really quick while we're waiting for things to print. Let me show you in here in PDF Candy. And I know sometimes it works and sometimes it doesn't. Sometimes it's glitchy. But you can take things apart and put them back together, okay? So if you guys know very well how to merge something together, right? So you could merge, if you're doing Cami and you had some stuff you wrote last week and you want to merge it with new stuff from this week, it does have a limit a little bit. So maybe go through and first grab whatever file that you need, that you wrote the new stuff on, delete pages, okay? So delete pages, and then take that new file and merge it with the old file. Okay, so you can use Cami to do that, or it's not Cami, but PDF Candy totally to do all of that. Okay, there's also a thing on here where it will let you, so when you're doing, remember how, oh, you guys haven't turned in notes yet, have you? I didn't have you turn in notes yet, did you? Okay, so when I have you turn in notes, I'm gonna have you do the learning log first, and then your notes, and then the table of contents goes last, just because then it titles it for you if you're using Rocketbook. That was the way I set it up. But you can, whatchamacallit, you can also rearrange pages, which I thought was super helpful. You get it in there, and then once you get file in there, you can move the pages around. So if you need something in a different order, I thought that that was super handy. So I don't know. I still like it, even though some people are having some glitchiness with it. So there is the other one that I found that it's a PDF converter or something, but there's another one there in case you just need to merge, and PDF Candy is acting glitchy. All right, I think that hopefully Gabby's ready to go because she's now printed her sheets and we're good to go here. All right, did I stalled enough? Okay, you're welcome. Glad I could help. Glad I could help somebody on a Friday. Okay, we are working on looking at the fundamental theorem of calculus, and we're kind of still going back to kind of the graphical representation of this, okay? So I'm gonna go ahead, I can probably unplug for a while, flip that. So we're gonna talk about how the area under the curve of the given, we're going to find, how do I find the area under the curve of the given graph? How do I solve a rate in, rate out problem? So basically I can find the area under the curve of a given graph, which we kind of really did last week, okay? And then I can solve a rate in, rate out problem. We're going to save that for Monday because that does not sound like something we should be doing on a Friday, okay? So absolutely, let's just deal with the basic fundamental theorem, okay? Oh, good. I'm on the wrong page again. Let's see if I can get to the one that isn't written on yet. There we go. All right, so let f be continuous on a to b. And so basically, we learned last year that this first one is basically saying that derivatives and integrals are opposites of each other, okay? So when I have a derivative, or a derivative, if I have an f prime inside and I integrate it, I get back to f, okay? And if I take the derivative of g, of this function that I'm integrating, when I take that derivative, this integral symbol will cancel, so g prime is actually in fact equal to f. We use that a lot when we're looking at this graphically, because they'll give us a function that looks, hey, g of x equals this, And then, hey, surprise, surprise, you got to do all your work off the graph, okay? And that AP is, you're pretty much 100% guaranteed to see that on the AP exam. You guys know that very well. You saw it last year. Then this is the fundamental theorem, traditionally what we saw last year, from a to b of f of x dx. When we integrate it, we get back to the original function, and we take and we plug in our limit. So this is what we would call definite integrals, okay? F is what we call, in that notation is called the antiderivative. We pretty much throw the word antiderivative and integral around interchangeably. I tend to use integral more than antiderivative. They're really the same thing, okay? It says the second part of this theorem has a particularly useful application in determining a function's value after it has undergone some amount of change. This is outlined in the theorem below. So really what we're getting at here on this one is that there is, remember when we had an initial condition? So this is the starting point, okay, or the initial condition. So remember that comes up a lot. That's going to actually come up today. This is usually whatever the integral is, or the, hold on, I'm going to pull out my notes and make sure I'm saying it the right way. This is what we call the net change. Okay. And then the f of b is what we would call the end amount. If you don't have Cami, but you have like an iPad, there's probably a way to do, and a one with a pencil, there's probably a way to take your notes on there on the PDF too, okay, and get it changed. So if you want to figure out that and play with it, 100% go for it, okay? All right. Are there textbook options too on an iPad? No. There are, oh, for Cami, to get our textbook into Cami, that's one big PDF file. I don't know. I haven't played with trying to put like the ebook, which is kind of connected through WebAssign, into Cami. Oh, for text boxes for our notes, all I would do is, because it's hard to type math. There are text box options in Cami. If they're on the right side, you have to just play. There's something that looks like a letter, like any text box would look like. I'm sorry, the left side. I can't tell my left from my right. The left side, there is something there. I would, for math, it's tough to type and go fast enough to keep up. So I would use Cami if you can use like a stylus and write. So using a mouse, I think, would be awful, okay, in Cami. All right, so we're going to find net area. So let f be the function whose graph consists of 2 straight line segments and 2 quarter circles. So the straight line segments are hidden. There's one here, and then there's one right there as a straight line segment. At first I look at that, I'm like, there's something wrong. No, there's a straight line segment right there. And then we're going to know that g of x equals the integral from 0 to x of f of t dt. Notice this is the graph of f, meaning that if I take the derivative of this, that I'm really looking at f of x. Okay, so I know that this graph is the graph of g prime as well, which will help us here in a minute. Okay. All right, so g of 0, I'm going to use this formula. Okay, so I'm just going to follow my rules. 0 to 0 of f of t dt. All right, help me out in the chat. When I integrate from 0 to 0, what do I get? I swear Gabby reads my mind. All right. Yes, you do get 0. Okay. And then we're going to do g of 1. So the integral from 0 to 1 of f of t dt. Okay. We're looking from 0 to 1. So we're looking at that triangle. So everybody find the area of that triangle right now. You should be able to do that. Now David's trying to, you guys, I didn't even ask you to put it in the chat. Good job, thank you. Have you guys finished the notes yet? Because I blabbed too much, so you all did them ahead of me. Okay, so we have 1/2 the base times the height, which is 1. Thank you for making me smile today. We're teaching, actually. Okay, great. Should I just stop and let you guys take over? Okay, I'll keep going. All right. Oh, I do know what I do need. I did, that's too far. Okay. I forgot to grab this extra. I need an extra little picture here. Let me grab it real quick. Okay. There we go. So now we got the picture in the right spot. Okay, so we can scribble on it again. I should have probably put a second one in there in the notes for you there. Sorry. Okay, we got to do g of 2. So we're going to go from 0 to 2 of f of t dt. All right, so 0 to 2. Okay, couple of things I could do. How would we integrate that one? What shape are we going to use? You do the Ballard commentary. See, you're going to miss it next year. You're just going to have to play YouTube videos in the background. But you have to play like the ones from last year, because those are the ones I recorded in class. Trapezoid, excellent. Could I use anything else besides a trapezoid? All right, good job. We could use a triangle and a rectangle. So it's up to you. We already know the triangles area. We could just, and then add the rectangle to it. I'm going to go for the trapezoid because I do know my trapezoid formula. At least I think I do. So we know that our bases would be 2 and 1. And then my height is 2. So it looks like my area of that one, or my integration of that one, is 3. Okay. Then we're going to do g of 4. So we're going to go from 0 to 4 of f of t dt. So 0 to 4. Okay, we've got our trapezoid. We already know that the trapezoid, though, is 3. I'm not going to recalculate that. If I already got it, I'm not going to try to redo it. And then we have, what kind of a shape do I have now that I just colored in green? Oh, it's a quarter circle. All right, it's okay. It's okay to make a mistake. I make them all the time, all day long. So, but I've been teaching this stuff for years. All right, so we got to divide by 4. And we've got pi times r squared, so that would be 2 squared. So these guys cancel. So this one, sorry, is not quite enough space. 3 pi plus pi. All right, this next one we're going to integrate from 0 to 6 of f of t dt. Okay, we have, so 0 to 6, we already know. We already know 0 to 4, don't we? We just have to get this last little bit here. We just have to get that bit. What's going to happen with the green bit and the purple bit? All right, they are definitely going to cancel, right? So really what I have is I know that this part here was, I know that that part was pi, and this part is technically negative pi. So I have 3 plus pi minus pi. So we would end up with 3 on that one. Because remember, when we're below the axis, we have negative area. All right, so remember that this graph, we wrote it at the beginning. This graph is f. What else is this graph representing? Put it in the chat for me. Good. We know that that's representing g prime. So these next ones, all I have to do is read the y value off of the graph, right? So I've got g of 1. So I'm going to go to 1 on the graph, and I'm going to read the y value off. It's 2. G of 4. It's so funny. Every time I teach this for the first time in trig, it's like they don't understand how important it is, this skill is, because we use it all the time to read these values off the graph. And like no textbook ever teaches you to do this. It's going to be 0, right? And then g prime of 6 is -2. Okay, we are supposed to be sketching a graph of this now, of g. It says to hit find values of g double prime. So what I'm going to do, well, actually, let's see if you can read my mind. What am I going to do first before I try to draw a graph? What would help me analyze what I have to help me draw a graph of the original? Gabby really does read my mind. Okay, so we are going to do a sign chart. All right, that's my go-to tool for pretty much everything, right? It's kind of like, you know, the 3 dots, right? The 3 dots. David, what on earth are you eating out of a, that bowl was as big as your head. So, though I'm glad to see you, okay? How are you eating oatmeal without a spoon? All right, let's do a sign chart. Oh my gosh. All right, I really miss you guys. Okay, we are looking at g prime, which is really just the f graph, and then we're also going to talk about g double prime. I'm going to put every little tiny mark on here. Okay, so I've got 0, I've got something going on at 1, I've got 1, I've got something going on again, it looks like at 4, and then I've got something, and then it looks like it ends at 6. Okay, so let's see what we can do with this. It looks like I am in, actually no, I've got to do something else in there. I missed one that I wanted to put in there. I want to also indicate this where it changes from that horizontal to the concave down. So I'm going from 1 to 2, 2 to 4, 4 to 6. All right, so first I am looking at above, below. So I'm above first, above again, and from 2 to 4, I am still above. I don't go below till I hit 4 to 6. Okay. Then now I am looking at increasing, decreasing. So increasing first, so that's positive. There is no increase or decrease, so neither, which means I have a constant slope. Okay, so it's constant there, which we don't typically indicate in a sign chart, but it's going to help us out here in a second. All right, we are definitely going decreasing, decreasing. Okay, so the first part, my first part says I have to be increasing and concave up from 0 to 1. So there's 0 to 1, increasing, concave up. Okay. From 1 to 2, I'm increasing, and I have a constant slope, meaning that slope is the value of whatever this is right here. So I actually have a slope of 2. So I know I'm going to go from here, and I'm going to go up 1 over 2. There's the slope of that line. And I know it looks like there's no curve. It looks like just one big long line right now. And I'm sorry. It's because of the thickness of my digital ink. All right, now I'm increasing, but I am concave down between 2 and 4. Whoops. Okay. 2 and 4, increasing, but concave down. And then I am decreasing and concave down between 4 and 6. So decreasing, concave down. Okay. I don't want to scroll too fast. I'd really like a sip of water, but I spilled it all on the floor. Yes, it was supposed to have G double prime. I can't tell if you put G prime or G double prime. It's supposed to be G double prime, because remember it would have had F prime. That's what I missed on it. Okay, let's take a look at example 2. So let F be a function defined by the closed interval from -4 to 4 with F of 0 equal to -3. Okay, help me out. What am I thinking? What is this originally called? What do we call that when we see something like that in the problem? All right, well, Gabby knows. It's the initial condition. I'm waiting for everyone else, but Gabby knows. All right, the graph of f prime, the derivative of f, consists of a semicircle and one line segment shown in the figure left. Find the following values. Okay, so this is f prime. I already know that I'm starting everything at -3. Okay, and I tried to do this some crazy way yesterday, or I'm not doing it that way. I'm just going to go back to what I always would have done. So I know I start with my initial condition, and then I always have to integrate from this initial condition to this value. So I'm going to go from 0 to -4 of f prime of t dt. Or I guess I could use x. It doesn't matter. F prime of x dx. What is wrong with my integral right now? Yeah, we want the -4 on the bottom, right? So we need to flip these and make it negative. So -3 minus the integral from -4 to 0 of f prime of x dx. All right, so we're going to use that to find the area. So I am going from -4 to 0. So I'm looking for this. How am I going to find this area? I need the what's in like the magenta purple color. How am I going to find that area? Tell me in the chat. Am I going to is it a circle and a square? Ah, area of half the circle from the area of a rectangle. There we go. Okay, so I am going to subtract, okay, and now I'm going to take my area of my rectangle, 1, 2, 3, 4, 1, 2. So 4 times 2, which would be 8. Then I have to subtract my semicircle. So it looks like I've got pi times 2 squared over 2. All right, so I'm going to go to simplify. -3 minus 8. One of those would go away, minus 2 pi. And then I'm going to distribute the negative. So when I go to distribute the negative, I get negative positive. So I would have -11 plus 2 pi. All right, we're going to start with our initial condition. And we're going to integrate from 0 to wherever this is. If that was a number other than 0, we would start with that number, by the way. Okay, so f prime of x dx. All right, so we've got -3 plus. I'm going to erase on my little graph and scribble again. So we've got to go from 0 to 3. So I've got two little tiny triangles, right? So I've got 1/2, 2 times 2 for this triangle, right? Base of 2, height of 2. Plus 1/2, it looks like base of 1, height of 1. 1 times 1. So -3 plus, those 2's are going to go away. So I get 2 plus 1/2. -3 plus 2 would be -1 plus 1/2. So -1/2. Something went wrong somewhere. What did I do wrong, guys? 4 halves, 3 halves. Oh, you know what? I think his thing was wrong because he didn't start with his initial condition. Okay, I'm going -1/2.
Miss Bowles,
yeah, go ahead.
Doesn't the triangle need to be negative since it's below the x-axis?
Yes, thank you. That might be where I went wrong. All right, thank you for catching that. Let's fix it from here. Okay, so I need to have a minus triangle there because it's below the x-axis. So that gives me -1 minus 1/2, and then we've got -3 halves because this could be 2 over 2. Thank you, Gabby. All right. And you all tried to tell me in the chat, and I wasn't looking at. Someone needed to sharpen his pencil. Okay. All right. Let's see what we can do. How are we doing on time? We've got enough time. I think we can get through this one. Now that I totally messed this one up yesterday. But I went through and I actually looked at it. So I know what I'm doing now. Okay, I should have just gone with what I knew how to do instead of trying to look at the work that I was looking at. So let f be a function defined. It is time for lunch. My tummy is growling. What is he doing? He's supposed to be at lunch. I wonder what my son's doing. I don't think he's probably eating like he's supposed to. Are you eating?
I'm coloring my drawing.
You're supposed to be eating lunch, dude. You have 10 minutes before class starts. All right. So we're on a closed interval. Notice we have our handy dandy initial condition again. The graph of f prime, the graph of the derivative, consists of 4 line segments and 1 semicircle as shown in the figure at the right. Ooh, we get to find an absolute maximum value. What am I going to use this time if I'm finding an absolute maximum value? We did about a bazillion of these last spring. Tell me in the chat. Gabby's all fancy. Endpoints and candidates, yes. We're going to use, what kind of a symbol or thing would I probably put those endpoints and candidates in? There we go. We're going to use a table or a T-chart, right? And I know I don't have a ton of space here. Okay. So what I'm going to do is we've already found, or I'm going to find those areas and go ahead and just stick them in the picture. Okay. So I'm going to cheat on it a little bit. So I'm going to find each one of these areas. So the area of this triangle here, it's 2 times 2 divided by 2, which would be, and it's underneath. So wouldn't that be -2 there? Okay. And then the area of this triangle would be 2 times 1 divided by 2, or the area would be +1. I'm going to do each of the semicircle or the quarter circles separately. So we know that it would be pi times the radius of 2 squared divided by 4. So this would just be underneath -pi and -pi. And then this one here, this triangle, we have, let's see, 1, 2, 3 times 2 divided by 2 would be an area of 3. And this little guy down here, right, 1 by 1 divided by 2 would be, and it's because it's underneath, -1/2. So I have my areas on there so I can kind of, that makes my T-chart work a little bit cleaner. All right, so this is x, this is going to be f of x, and I'm going to pick all of my candidates, okay, and my endpoints. So I'm basically looking, remember my candidates are my zeros. So I'm going to find all of my zeros on here, and then my endpoints. So I'm going to use -4. I'm going to use -2. I'm extending my T-chart over here because I did not give you enough space. And then it was -2 and 2. And then 5, and then 6. Okay, so we are always starting with, and I'm gonna have to write tiny, I should have left more space between my charts. And we always start with our initial condition. And remember, I'm integrating from this to whatever number they give me. So I'm integrating from 0 to -6 of f prime of x dx, which means I did not give myself enough space. I'm going to erase mine, sorry, if I put it too close for you guys. Which means that I'm really doing 3 minus the integral from -6 to 0 of f prime of x dx. So I have the 3. And then I need all of these numbers in here, right? It's going to be minus parentheses -2 +1 minus pi. I distribute that negative, and then I end up with 4 plus pi. All right, we're going to put in the -4. So I'm going 3 plus from 0 to -4 of f prime of x dx. Okay, so I'm starting with 3. I have to swap them because they're not in the right order. F prime, that's 0 on top of x dx. So if I'm only going from 0 to -4, I have 3 minus parentheses 1 minus pi. So if once I distribute and I get my final answer, I get 2 plus pi. Okay, looking at the next one, again, I'm starting with 3, and I'm going to go from 0 to -2 of f prime of x dx. And then I definitely need to make this one 2 pages next year, put it on its own page, huh? 3 minus the integral from -2 to 0 of f prime of x dx. And we've got 3 minus, and then it's just going to be that pi, so it's going to be negative pi, which is going to be 3 plus pi. Okay, x, f of x, and we still need to do 2, 5, and 6, and we're looking for the maximum, okay? So the biggest number. All right, we're starting with 3 always, plus, because that's our initial condition, and we're going to go from 0 to 2. So the good news on this one is I don't have to flip it around because my integral's in the right order. So 3 plus from 0 to 2 is negative pi. So I could have just done 3 minus pi. 3 plus from 0 to 5, f of x. So 0 to 5, looks like I get the negative pi and the 3. So we get 3 plus negative pi plus 3, which is just going to be 6 minus pi. All right, and then finally 6, we're starting with 3. We're going from 0 to 6 of f of x. Oh, I forgot my dx's on everything, didn't I? dx, dx, dx. All right, we've got 3, and then from 0 to 6, I need all of that stuff, right? So we've got negative pi plus 3 minus 1/2. So I've got 6 minus 1/2 minus pi, or isn't that like 11/2 minus pi? All right, so what's our biggest y value? Remember, pi is like the number 3. You can estimate it at 3 because this one would not have a calculator on it. So what's my biggest number or my maximum value? All right, Lorenzo's got it. So I started writing our nice little concluding sentence. Therefore, our absolute max value of f of x on -6 to 6 is 4 plus pi, and it occurs at x equals -6. On the AP test, what did this one ask? It asked for the maximum value. So they were looking for that because it said the word value. It doesn't hurt to put both the x and the y, and then you've covered your bases when it comes to something like this. Okay, I think I'm done. I think we need a joke of the day. All right. He mispronounces a word in this joke. The word he mispronounces is masseuse. Okay, so he couldn't read masseuse. He reads it like a 7th grade level, but he couldn't pronounce masseuse the other day. You don't know what a masseuse is? It's somebody who gives you a massage that you pay a lot of money for too, and they give you a massage at like the spa. So let me find the jokes. Okay. Let's see. Oh, I think it was in, I can't remember which one it was in. Oh, let's see, what was the date? It was yesterday's date, September. Oh, he do a new one today? He did a new one today, it looks like. Maybe we'll see if we've got the new one today. We'll do yesterday's and today's if you guys want to hang out for the extra minute, okay? All right. Okay, I got to share it. Sorry. He told me he ran out of jokes, so I printed him a bunch more. Sorry. Yes, Gabby, -6.
Thanks to this math pack right here, I have got the power to read you lots more jokes. So here we go. Sorry. Why did the 1/5 go to the mosaic?
Masseuse.
Because it was 2/10. I know you guys.
Why did the 1/5 go to the masseuse? Because it was 2/10. Okay, let's go back. He's got a new one today. I haven't heard this one yet, so.
Okay, what did the triangle say to the circle? You're pointless. And guys, check out what I can personally do in under 1 minute. Okay.
He's learning how to tie his shoes.
Okay. We're almost there.
You can't see
Okay,
what he's doing.
here we go.
Oh my God. I had to drop my husband off at work today because we let someone borrow the truck to take somebody into college. There you go.
I can't
You learned how to tie his
a
shoes.
bow.
Okay. All right. I see some third
I
graders know how to do that.
get it. It's like a rectangle, like a triangle. Cause
All right. Well, you all, class is over. I hope you all have a great weekend. Please, 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 get your videos in by 5. Okay. All right. I will see you on Tuesday.
So